Okay, we're on page 2 now of the practice exam. What intermolecular forces does the following molecule have? This one is pretty much the same molecule as the page before, in that it has a local dipole that points from the carbon to the chlorine. It's a local dipole, but that's also the overall dipole. And because of that, I'm already confident that definitely has this one, but it also has dispersion forces, so I shouldn't have circled that right away because it's got both A and B is the correct answer to this question. Everything has dispersion forces. Only some things have dipole-dipole forces, those things with permanent dipoles. And this molecule does not have a hydrogen bonding. It doesn't have the OH group or the NH group that we're looking for. As opposed to this next example, which has hydrogen bonding, therefore it has all the intermolecular forces, I'm already immediately concluding that this is, all the above, essentially. And that's definitely true. Now, this one is a tricky one. This one actually is, first of all, the shape of this is trigonal pyramidal, which is important. But the key thing about this one is, even though it looks like it's going to be a hydrogen bonder, it is not, actually. The nitrogen has no hydrogen attached, but because it's trigonal pyramidal shape, it does have a permanent dipole. So I conclude that it's got both dipole-dipole and dispersion forces. So answer is D in this case. Okay, so we're looking at intermolecular forces. Now let's scroll down a little bit. Okay, the last of the multiple choice on this page is rank the following sets of molecules in order of increasing boiling point. And as I look at this list, this is the highest for sure. It's got the most carbon, or it's the biggest, but it also has hydrogen bonding. I don't know what is going on with my pen today. It's really slow. That is terrible. It should have said highest. I mean, this is the highest for sure. So I'm immediately removing A and B from this. It can't be these two because 3 is the highest boiling point. The second highest boiling point is going to be 4. So I'm thinking it's the answer is C. The reason why 4 is the second highest is because it's got 5 carbons joined in a row, and it's got a linear shape versus a spherical shape, which is 1. So therefore, this one has more surface area in contact. I mean, this one has the same number of carbons and hydrogens as this one, but the shape is ideal for maximizing the dispersion forces. So C is the answer because this one's next. And then finally, this is the lowest boiling point right here. Okay, so that's it for those multiple choice questions. Now let's look at molarity, and you're sure to get some molarity questions on the test. And molar concentration means that we're after capital M, also known as little mol, over a liter. And keep in mind, it is not equivalent to M over L. So if you do this at any stage on your test, I'm going to be merciless when it comes to that, okay? So we have to choose between capital M and little mol over L, which this is convenient because we're going to use dimensional analysis to solve this. Starting with the 5 grams, I know always that I can convert gram amounts into moles using the form of mass. And I need to do that for calcium chloride. 110.98 grams per 1 mole. So I've got the top part of this taken care of. Now I need the bottom part to finish off the molarity. So I'm going to put, this is strange, but I'm going to put a 1 placeholder on top and divide by the volume that I need. I have to do this because molarity is moles on top and liters on the bottom, hence the placeholder. Don't convert the milliliters into liters on the fly. Instead, do this. I still do this. I don't try to convert on the fly. So 1,000 milliliters per 1 liter. And now everything's set up properly. I'm going to calculate this. Okay, so with sig figs in mind, which I have 4 to work with, so let's just do this. 9.1. Oh, not 9.1. 9.011 times 10 to the negative second molar. Okay, so molarity calculations are quite common in chemistry, and just recall that moles on top, liters on the bottom. As my guide for setting up the dimensional analysis, I had to convert grams into moles and then divide by the total volume in liters, and that's this part of it. The 1 here is just a placeholder. Don't let that freak you out. It's just to force the 500 milliliters to the bottom. The volume has to be on the bottom. Okay, so that's it for page 2.